Alrighty then, corn children, children of the corn. One more lesson on sequences, specifically pairing it up with the very natural sigma notation. Sigma notation, of course, means that we're going to be adding up our sequences. Of course it does. Now, let's be clear. I am perfectly aware that the graphing calculator can and will do sequences and summation for you. That's not really the point. Let me remind you though, alpha key, the F2 shortcut key, the second one down. Yes, you can straight up type these in. Yeah, great. But if you have no clue what you're doing, how helpful is this? So what I'm going to be doing today is not just typing this in. Yeah, check your work that way, of course. But I want you to actually understand what the Haiti-ho is going on here. All right, so we're going to break this down a little bit further. Now, this should be a little bit review at the start. What on earth does this mean? Here's what this means. Starting with 0, because it says 0, I would fill 0 in to the I value. Because it is a sigma notation, it is automatically adding with. After you fill in 0, the next number is 1. These are the counting numbers. I would fill in a 1. Add it up. I would fill in a 2. Add it up. I would fill in a 3. Whoops, well, extra parentheses. All right, now some of you are still dazed and confused about this. The number of numbers. When we talk about sequences, the number of numbers is called n. It's n, numbers. Okay, so 0 to 3 makes 1, 2, 3, 4 numbers. 0 to 3 is not 3. 0 to 3 is 4 numbers. And you can figure out the n value by taking the top number minus the bottom and then always add 1. So yes, 3 minus 0 plus 1 is 4 terms. Yeah, that's right, people. Fill in a 0, fill in a 1, fill in a 2, fill in a 3. There are 4 numbers. Now, of course, we could add those up. That's not the point we're focusing on. How do we find n when given sigma notation? It's the top index number minus the bottom index number, add 1. Okay, what about this? Oh, look what I've done. I didn't start with 0, I started with 10. Well, what would this mean? This would mean fill in 10, go up by 1, fill in 11. These are the counter numbers, the counting numbers. 12, whoops, and 13. I want you to notice 10 to 13 is still 4 terms. The number of numbers would be 13 minus the 10 and then add, whoops, not 11, add 1. Yeah. Check it out. 10 plus 11 plus 12 and then 13. You fill in a 10, an 11, a 12, and a 13. That makes 4 numbers. Yeah. All right, let's check out this next one. In this next problem, wow, yeah, I know, right? 6,000, woo! All right, so unless we're just going to type this into our sigma notation, how do we handle this problem? Here's how I would do this. First thing I'm going to do, I'm going to figure out how many terms there are. the number of terms would be 6,000 minus 3, and then add 1. So our number of terms, 5,998, not 7, 8, 98. Now, if I wanted to figure out how to add these up, I would suggest that we first figure out what the heck is going on with this expression. So I would fill in the first few terms. I would fill in a 3. The next number after 3 is 4. Then I'd fill in a 5. Whoops, I forgot the minus 1. Minus 1. Yada, yada, yada. The last number that I would fill in would be 6,000. So my very last term is 7 times 6,000 minus 1. I would go ahead and figure some of these out just to get a feel for what's happening here. This is going to be 20, 27, 34, yada, 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 41,999. Well, let's look at this sequence real clearly here. This appears to be arithmetic. Aren't we adding 7 to get from one term to the next? It's arithmetic. It's important to identify what kind of a sequence it is so you know what's happening. Once you identify what kind of sequence it is, you'll know which formula to use. If you need to, go back to the videos on arithmetic sequences and review those. The formula, n over 2, a1 plus an, and we are adding up the first 5,998 terms of this sequence. I know we did 3 to 6,000, but when we look at this sequence, this is now the first term. This is the second term, the third term, and this would be the 5,998th term of this sequence. I'm in essence re-indexing the numbers. So n 5998 over 2, a1 is 20, the first answer that we got from filling in the first index number. I filled in the first index number, and that gave me the first term of my sequence. To get the last term, I filled in the last index number in, and I got the last term of the sequence. We can now math this out, and I've already done that. I think I did it right. If not, well, send me angry emails. All right, and that's the sum. Now, of course, you can justify this and check this with your sigma notation button, but I don't want you to just type stuff in. I want you to understand what you have. Okay, well, that's an example that the sequence was arithmetic. Maybe we should do another example. No way! Yeah, I got one right here. All right, so let's check this one out. This sequence goes from 3 to 10. The counter numbers are from 3 to 10. So the first thing I'm going to do is I'm going to figure out how many terms are in the sequence. Top of the index minus the bottom plus 1. There will be 8 numbers in this sequence. To find the first one, we would take 3, the first counter number, and fill it in. So it would be 256 negative 0.5 to the third. The next one, 256 negative 0.5 to the fourth, and so on. The last term would be 256 negative 0.5 to the 10th. I'm going to go ahead and figure out these first few. I've already done that somewhere here on my paper. Oh yeah, here they are. And this is negative 32. This turns out to be positive 16. If I keep going, the next one is negative 8, positive 4, yada, 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 until I get to this last one. And to be perfectly honest, I don't even care what it is, but there is a last term. It is not infinite. We are not adding forever. It is finite because we have a stopping point. Now, look at this sequence. Look right here. If you look at this sequence, you're probably going to know that to get from here to here, what are we doing? We are multiplying by a negative 0.5 each time. It is geometric. Once you identify that it's geometric, it is not going forever, we have a formula. So you're going to want to look up 8 terms. You're going to want to look up, go back to the videos if you need to, and look up the formula. You need to know which type of sequence it is to know which kind of formula to use. From here, you do want to type super carefully. The first term is negative 32. Our R value is negative 0.5. There were 8 terms over 1 minus negative. Yes, that cancels 0.5. They don't cancel here because of order of operations. You want to type that in carefully, and our answer should be negative 21.25. All right, one more example. Check out this next one, this last one. All right, what have we got going on here? Well, first of all, here's the terrifying part. It's infinite. It's infinite. If you've not already watched the video on infinite geometric sums, I suggest you look at that. All right, so the number of terms isn't like 10 or 12, it's infinite. All right, so let's look at our sequence here. I'm going to start off, I'm not going to fill them all in because you'd be here forever. I'm going to start by filling in the 1. So the first term would be 81, 2/3 to the first, adding. Next term, 81 times 2/3 squared, plus 81 times 2/3 cubed, and so on infinitely. Infinitely. Now, just for the fun of this, I have written out some of these. If you do the math, this is 54, this is 36, this is 24. If I keep going, it's 16, and so on forever. Now, if you look at this notation, I think it's pretty clear to get from here to here, you've multiplied by 2/3. If you're not sure up here, do the math and then take any 2 terms and divide. The second one divided by the first one kicks out our R value. And in this case, we are multiplying by 2/3. Every time, not just some of the time, every time. So yes, here's what I know. It is geometric. It is infinite because of the ... because of the googly eyes up here. And the R value is 2/3. Here's what's important about that. 2/3 is between -1 and 1, which makes it a convergent geometric infinite sum. So, because we know all of this, we know what formula we can use. The infinite sum will be A1 over, that's a little teeny subscript, really, trust me, over 1 minus R. Hey, I want you to notice something here. Remember our other formula? In the condition where n goes off to infinity and r is between -1 and 1, this term ends up turning into 1 minus 0. This part ends up heading towards 0, and we get a sub 1 over 1 minus r. There's your formula for the infinite sum nested within the finite sum. I know, that's awesome. Woo! Yeah, okay. So back to here. A sub 1 is 54. Put 54 up here. 1 minus the r value is 2/3. We do 54 over 1/3. We multiply by the reciprocal. And our infinite geometric sum has a finite answer. Wow. I know.